Hello class, in this video I'll be showing you how to find both first-order partial derivatives when the derivatives require the quotient rule. Well, let's begin. So at the top of the page, I'm highlighting in blue the quotient rule. In purple, I'm highlighting the chain rule for exponential functions. Both of those are going to be required to find the partial order derivatives of this rational expression that I just highlighted in red. And we're going to start with the partial derivative with respect to x. And remember, when we want to find the partial derivative with respect to x, y is going to be treated as a constant or a coefficient. So what I've done is I've already rewritten the function where all the constants and coefficients are pink. So to apply the quotient rule, I'm going to work with the numerator and the denominator individually so I can get the parts that I need to put the quotient rule together. So I'm going to label the numerator g of xy. And the partial derivative with respect to x of the numerator is 3y times 2x. So that is going to equal 6xy. Now for the denominator. You can label the denominator whatever letter you like, except for G and except for F, because both of those letters are already taken. So I decided to use M. So here's the denominator. And the partial derivative with respect to x of the denominator is the following. It's going to be y times e raised to the y times x power. And the derivative of 2 is 0, so I'm not going to write that down. And so now that I have all the pieces, we can now find the partial derivative of, with respect to x of the entire function. And that starts with the partial derivative of the numerator times the denominator. And then we're going to subtract the product of the numerator and the denominator, or the partial derivative with respect to x of the denominator. And this difference is going to be divided by the denominator squared. So I'm going to go ahead and distribute the 6xy to the two terms in the braces here, over here on the left. And I'm going to multiply the two factors over here to the right side of the subtraction symbol, and you'll get the following. And finally, we can factor out a 3xy. So when we do that, we'll get the following. And here is the partial derivative with respect to x. Okay. Now we can evaluate this partial derivative when x is equal to 3 and y is equal to -1. And I'm just going to write down the result so that you, on your own time, can do this on your own and get the same result. Okay, now it's time to find the partial derivative with respect to y. And before we do that, I'm just going to shrink all of this work here. That way we have more space. Okay, so remember, when we want to find the partial derivative with respect to y, we're going to treat x as the constant or x as a coefficient. And I've already gone ahead and written all constants and coefficients in green. So I'm going to do the same thing that I did when I wanted to find the partial derivative with respect to x. I'm going to take the numerator and the partial derivative with respect to y of the numerator, and I'm going to take the denominator and find the partial derivative with respect to y of the denominator. So here we go. So for the numerator is still the same. But now we want the partial derivative with respect to y. And in this case, that is just 3x squared. We're going to label the denominator m again. And the denominator hasn't changed. But this time the derivative with respect to y is going to be x times e raised to the xy power. And again, the derivative of 2 is 0, so I'm not going to write that down. So the partial derivative with respect to y of the entire function is the following. It's the partial derivative of the numerator times the denominator minus the product of the numerator times the partial derivative of the denominator with respect to y. And again, we're going to divide this entire expression by the denominator squared. Okay, after multiplying and combining like terms, the result will be the following. And this is the partial derivative with respect to y. And now that we have that partial derivative, we can evaluate the partial derivative when x is -2 and when y is 0. Okay. So if we substitute -2 in for x, the first expression is going to be 12. Then we have e to the 0 power plus 2 minus 0, all divided by e to the 0 power plus 2 squared. Now please be careful. E raised to the 0 power is 1. And e raised to the 0 power is still 1. So this will be 36 divided by 9, which equals 4. And we are done.